In this video, we're going to talk about transformations, translations, reflections, and rotations. So let's start with translations. So let's say if we have a circle in quadrant 2 and we wish to translate the graph 5 units to the right. The x value is going to increase by 5. So you're going to get a new picture, which most likely will be in the right side of the graph. So that's shifting the graph towards the right. Now let's say if we have a translation that's 5 units down. So this graph and all the points that it contains will go down 5 units. You have to decrease the y values by 5. Now let's say if you have a figure in quadrant 3, and let's say we wish to translate the graph, let's say 7 units to the right, and let's say 5 units up. So we're going to have to travel 5 units up, and then 7 units to the right. So most likely the graph will be in quadrant 1. So that's the main idea behind translation. So basically you're moving the same image either to the left, to the right, up, or down a coordinate plane. But let me give you a specific example. So let's draw a graph first. Let's call this point A, B, and point C. Translate the graph 5 units to the right and 4 units down. So if you move it to the right, it's going to be in quadrant 1. And then if you move it down, most likely it's going to be in quadrant 3. So therefore, we should have some figure. This is quadrant 4, by the way. We should have some figure in quadrant 4 that looks like this. It should have the same size, but in a different position. Now, the best way to go about doing this is to find all the points of the original figure. So point A, if you look at the graph carefully, point A is at -4, 1. Point B is located at -2. I'm going to say it's closer to -2 than -3. And it has a y value of 3. And then point C is located at -1, 1. So that's for the original figure. Now, to find the points of the new figure, we need to add 5 to the x values because the graph is going to be shifted 5 units to the right. And then we need to subtract 4 from the y values. So this is the original point A. It's -4, 1. And then we're going to add 5 to the x values and then subtract the y values by 4. So -4 plus 5 is 1. 1 minus 4 is -3. So the new coordinates for A are 1, -3. Now let's do the same for B. So B is at -2, 3. and then we're going to add 5 to the x-coordinate and subtract the y-coordinate by 4. Negative 2 plus 5 is 3. And 3 minus 4 is negative 1. So this is the new coordinates for B. It's 3 comma negative 1. Now let's follow the same procedure. Okay, what just happened? Let's follow the same procedure for point C. Negative 1 plus 5 is 4. And then if we add 1 and negative 4, that's going to be negative 3. So the new point for C is located at 4 comma negative 3. So now all we need to do is plot the new points for A, B, and C. And then we could graph the figure. So point A is located at 1, negative 3, which is here. And then point B is located at 3, negative 1, and C is located at 4, negative 3. So as you can see, we shifted the graph 5 units to the right, and then 4 units down. And so it should be in this quadrant. For the sake of practice, let's try another example. So let's say this is point A, B, C, and D. What I want you to do is pause the video and shift the graph 7 units to the left and 6 units down. So follow the same process, and then once you're ready, once you finish it, unpause the video to see if you have the right answer. So the first thing we need to do is identify all of the original points. So point A is located at 1, 1. Point B is located at 2, 4. Point C is located at 5, 4. And point D is located at 6, 1. So now to each of these points, we need to travel 7 units to the left. So therefore, we're going to subtract the x values by 7, or just add negative 7 to it. And now we need to go down 6 units. So we got to decrease the y values by 6. So we got to add negative 6 to it. So let's start with the x values. One plus negative 7 is negative 6. 2 plus negative 7 is negative 5. 5 plus negative 7 is negative 2. And 6 plus negative 7 is negative 1. So now let's focus on the y values. 1 plus negative 6, that's going to be negative 5. And then 4 plus negative 6 is negative 2. And 4, well, that's going to be the same. So B and C has the same y value. And 1 plus -6 is -5, just like point A is. So now that we have the new points for the translated image, let's go ahead and plot those points. So the new point for A is at -6, -5. So that's somewhere in this region. And then B is now at -5, -2. C is at -2, -2. And D is located at -1, -5. So this is the new point for A, B, C, and D. So we traveled 7 units to the left, and then we traveled down 6 units. So that moved the quadrilateral from quadrant 1 to quadrant 3. Now let's talk about reflections. There's 3 reflections that you may need to know. A reflection over the x-axis, over the y-axis, and over the origin. By the way, for those of you who may not be familiar with quadrants, this is quadrant 1, where x and y are both positive. In quadrant 2, x is negative, y is positive. And this is quadrant 3, where both x and y are negative. And in quadrant 4, x is positive, y is negative. So let's say if we have a triangle in quadrant 1, and we wish to reflect this triangle over the x-axis. So this is the x-axis, and here is the y-axis. How will the image look? How can we draw? If you're going to reflect something over the x-axis, it's going to move from quadrant 1 to quadrant 4, and it's going to flip at the same time. So the new image is going to look like this. As you can see, the x-axis is basically the line of symmetry. The blue line, the blue triangle, is basically a reflection or a mirror image of the red triangle, where the x-axis, you could think of it as the mirror or the line of symmetry. So that's how you can reflect an image over the x-axis. So let me give you another example. So let's say if we have a trapezoid in quadrant 2 and we wish to reflect it over the x-axis. So all you got to do is you need to move the trapezoid to quadrant 3. It's going to move from quadrant 2 to quadrant 3, and then you need to flip it. So notice that the long side is closer to the x-axis. When you draw in quadrant 3, the long side will still be closer to the x-axis. It's going to have the same length. Okay, let me do that better. It's going to be just as long, but it's just flipped over the x-axis. So my drawing is not perfect, but hopefully you get the picture. Now here's what you need to know. Anytime you want to reflect something over the x-axis, you need to multiply the y-coordinate by -1. So in the first example, let's say we have some point x comma y. That new point is going to be located at x, -y. So all you got to do is multiply the y-coordinate by -1. That's how you can reflect it over the x-axis. Looking at the second example, let's focus on this point. It's in quadrant 2, so x is negative and y is positive. To reflect it over the x-axis, the new point will have the coordinates -x, -y. As you can see, this is still on the left side, so x is still negative. It's in quadrant 3, but y is negative in quadrant 3. So the net effect is that we only change the y coordinate. We're going to multiply the y coordinate by -1. The x coordinate doesn't change when you're reflecting over the x-axis. Now let's talk about reflections over the y-axis. So let's start with our triangle again in quadrant 1. So when you reflect it over the y-axis, it's going to flip over the y-axis. So you're going to get an image that looks like this. Now let's say if you have some point x comma y. The new point will be -x comma y. So when you're reflecting over the y-axis, you need to multiply the x coordinate by -1. Let's look at another example. So let's say if we have a trapezoid in quadrant 4 and we wish to reflect it over the y-axis. So it's going to move to quadrant 3. So therefore you're going to get an image that looks like this. And that's basically it. So if we focus on a single point in quadrant 4, x is positive, y is negative. And when we reflect it over the y-axis, multiply x by -1, so it becomes -x, -y, which in quadrant 3, x and y are both negative. So, to review what we just went over, anytime you wish to reflect a figure over the x-axis, multiply the y coordinate by -1. If you wish to reflect it over the y-axis, multiply the x coordinate by -1. Now the next thing that we need to talk about is a reflection over the origin. So let's say if we have a triangle in quadrant 1. What's going to happen if we reflect it over the origin? So to reflect it over the origin, it's going to move from quadrant 1 to quadrant 3. Reflection about the origin is equivalent to reflecting it over the x-axis and then the y-axis. Or it could be over the y-axis first and then the x-axis. So if we reflect it over the y-axis, the graph will look like this. And then if we reflect the green triangle over the x-axis, it's going to look like this. So going from red to blue, that's a reflection about the origin. Now, if we want to reflect it over the x-axis first, it's going to look like this. And then if we reflect it over the y-axis, it's going to move from quadrant 4 to quadrant 2, and it's going to be the same image. So the order doesn't matter. Now, when you want to reflect an image or figure from or about the origin, you need to multiply the x and the y value by -1. So this is going to change to -x, -y. So here's another example. Let's say if we have a figure that looks like this, and it's in quadrant 2. Draw a rough sketch of the image after reflection about the origin. So it's going to move from quadrant 2 to quadrant 4. So if we reflect it about the y-axis first, it's going to look something like that. And then if we reflect it over the x-axis, it's going to look like this. So basically, the blue image is a reflection of the red image about the origin. Now let me change the structure. Let's say if we have a shape, an unusual looking shape like this. Let me make sure that one side is smaller relative to the other side. reflect that image about the origin. So let's reflect it about the y-axis first. It's going to look something like that. And then if we reflect it about the x-axis, it's going to look something like this. So this, the red one, is a reflection of the blue one about the origin. Or the blue one is a reflection of the red one about the origin. That's what I meant to say. So if we focus on a point, the x value in quadrant 2 is negative, the y value is positive. To reflect it about the origin, multiply the x and the y by -1. So that point will be here. It's going to be positive x, negative y. So change the sign of both coordinates anytime you need to reflect it about the origin. Now let's work on some examples. So I want you to reflect this image about the x-axis. Let's call this point A, point B, point C. So go ahead and reflect it about the x-axis. So point A has the coordinates -6, 1. Point B is located at -4, 4. And point C, that's located at -1, 1. Now, in order to reflect it about the x-axis, we need to multiply the y-coordinates by -1. So therefore, the new points for A, B, and C are going to be, so all of the x values will stay the same. Just change the y values. So 1 is going to change to -1. +4 will change to -4. And this value will also change to -1. So now we could plot the new figure. So let's say here's -1. So the first point is at -6, -1, which is here. The next one is at -4, -4, and then -1, -1. So this is going to be A, this is B, and this is C. As you can see, it's a reflection about the x-axis. It's a mirror image about the x-axis. Now let's work on another example. Go ahead and reflect this image about the y-axis. Let's say this is point A, B, C, D. So feel free to pause the video and work on that example. So let's find the coordinates of each point. So point A is located at 2, 1. Point B is located at 3, 2. Actually, that's not 2. That's a y value of 3. So it's located at 3, 3. And C is located at 5, 4. And D is located at 6, 1. So to reflect it about the x-axis, I mean not the x-axis, but rather the y-axis, we need to multiply the x values by -1. So now let's find the new coordinates. So instead of +2, it's going to change to -2. The y value will remain the same. So this is going to become -3. And then instead of 5, 4, it's going to be -5, +4. And d is going to change from 6, 1 to -6, +1. So A is now located at -2, 1, which is here. B is located at -3, 3. And C is located at -5, 4. And D is located at -6, 1. So that's the reflected image over the y-axis. So all you need to do is multiply all coordinates, all x coordinates by -1. Try this example. Reflect this image about the origin. So let's call this point A, B, and C. So take a minute, pause the video, and reflect it about the origin. So let's find the coordinates of points A, B, and C. A is located at -4, -1. B is located at -1, -1. And C is located at an x value of -1, but a y value of -5. So now, let's find the new coordinates. Anytime you want to reflect it about the origin, multiply the x and the y coordinates by -1. So A is going to change from -4, -1 to +4, +1. B is now going to be 1, 1. C is going to be 1, 5. So now let's go ahead and plot it. So A is at 4, 1. B is at 1, 1. C is at 1, 5. So this is the new point for A. This is B, and that's the new point for C. So that's how you can reflect an image over the origin if you have all the coordinates of the original figure. Now the last thing that we need to talk about are rotations. So let's say if we have a triangle in quadrant 1 and we wish to rotate it clockwise by 90 degrees. So if it's in quadrant 1 and we rotate it clockwise, it's going to be in quadrant 4. And it's going to look like this. So let's say if this is A, B, and C, this point is now A, this is B, and this is C. If we make it a right triangle, C is the hypotenuse of the right triangle. So that's rotating the figure 90 degrees clockwise. Now what about rotating the figure 90 degrees counterclockwise? So let's start with the same original picture. If we rotate it counterclockwise, it's going to move from quadrant 1 to quadrant 2. So therefore, you're going to get a picture that looks like this. So using the same letters, this is now point A. That's a B. And this is C. So that's a 90-degree rotation counterclockwise. And the first example was in the direction of a clock. Now, what about rotating a figure by 180 degrees? The direction that you choose to take doesn't matter. Right now, we have a triangle in quadrant 1. And if we choose to rotate it by 180 degrees in a counterclockwise direction, it's going to move from quadrant 1 to quadrant 3. If we rotate it in the clockwise direction, it's still going to end in quadrant 3. And you're going to get the same exact shape. So a rotation of 180 degrees has the same effect as reflecting a graph across the origin. So this is C, this is A, and this is point B. Now, if you need to rotate the graph by 180, all you need to do is change the coordinates. You need to multiply each coordinate by -1. So if you have the point x comma y, it's going to change to -x, -y. If you need to rotate it by 180 degrees. Now let's say if you want to rotate it 90 degrees clockwise. And let's say the original point is in quadrant 1. It's xy. What you need to do is you need to switch the coordinates of each point. So it's going to be y comma x. And then the new second coordinate, you need to multiply it by -1. So this is the new second coordinate. Now, in the case of a rotation that's 90 degrees counterclockwise, you're going to switch the coordinates once again. But this time, you're going to multiply the first coordinate by -1. Let's try an example. Go ahead and rotate this figure 90 degrees clockwise. So let's say this is point A, B, and C. So let's begin by writing each point. Point A is located at 2, 1. Next, we have point B, which is located at 5, 4. And point C is located at 5, 1. So to rotate it clockwise, what we need to do, if we're going to rotate 90 degrees clockwise about the origin, we need to switch the coordinates and then multiply the second coordinate by -1. So let's find the new values. So first, we're going to switch 2, 1, and it's going to become 1, 2. But the second coordinate, we're going to make it negative. For B, instead of 5, 4, it's going to be 4, 5, but -5. And for C, it's going to be 1, -5. So now let's plot the new points that we have. So the first one is at 1, -2, which is right here. The next one is at 4, -5. And the next point's at 1, -5. So this is the image that we now have. So this is A, B is at 4, -5, and this is C. So as you can see, we've rotated it 90 degrees clockwise. Let's try another example. So rotate this figure 90 degrees counterclockwise. So go ahead and take a minute and work on this problem. So first, let's write the 3 points that we have. Point A is located at 2, 1. Point B is located at 5, 1. And C is located at 7, 5. Now, if you want to rotate it 90 degrees counterclockwise, the first thing you need to do is switch x and y. And then you're going to multiply the first coordinate by -1. So we're going to switch to point 2, 1, and it's going to become 1, 2. And then multiply the first coordinate by -1. We're going to switch 5, 1 into 1, 5. And then add a negative sign to the first coordinate. And 7, 5 is going to become 5, 7, but we're going to multiply the first coordinate by -1. So all of these points, they're located in quadrant 2. So the first one is located at -1, 2. Which is here. The second point is -1, 5. The third point is -5, 7, which I'm running out of space, so I'm just going to put it on top here somewhere. So that's a rough sketch of what the new graph should look like. So this is A. This is B, and this is C. So it rotated 90 degrees in the counterclockwise direction. So we're going to look at one final example. Go ahead and rotate this figure by 180 degrees clockwise. So let's call this A, B, C, and D. So go ahead and work on this problem. So A is located at 2, -1. B is located at 5, -1. C is located at 3, -3. And D is located at 1, -3. Now, when rotating it about 180, regardless of the direction, all you need to do is multiply the points by -1. That's all you have to do. So A is going to change from 2, -1 to -2, +1. B is going to become -5, 1. C is going to change to -3, 3. And D is going to be -1, +3. So the points x, y will change to -x, -y. Just multiply each coordinate by -1. So A is at -2, 1. And then B is at -5, 1. So that's A, this is B. And then C is located at -3, 3. and D is located at -1, 3. And that's it. So if you take it one step at a time, you can easily plot the rotation or reflection. Now I want to show you one of my algebra courses that might be useful to you if you ever need it. So go to udemy.com. Now in the search box, just type in algebra and it should come up. So it's the one with the image with the black background. So if you select that option, and if you decide to go to course content, you can see what's in this particular course. So the first section, basic arithmetic, for those of you who want to focus on addition, subtraction, multiplication, and division. And it has a video quiz at the end. It's a multiple choice video quiz. You can pause it, work on the problems, and see the solutions. It covers long division, multiplying two large numbers, and things like that. The next tutorial is on fractions. Adding, subtracting fractions, multiplying, dividing fractions, converting fractions into decimals, and so forth. So you can also take a look at that. Next, solving linear equations, which we covered, and just more examples if you need more help with that. The next topic, order of operations, which is also useful. Graphing linear equations. You need to know how to calculate the slope. You need to be familiar with the slope-intercept form, standard form, and just how to tell if lines are parallel, perpendicular, and so forth. And there's a quiz that goes with that as well. The next topic is on inequalities and absolute value expressions, which are also seen in a typical algebra course. And then we have polynomials, and that's a long section. And then factoring, that's another topic you need to master. And then system of equations. You can solve it by elimination, substitution. There's also word problems as well. Sometimes you got to solve equations with 3 variables, x, y, and z. So that could be helpful. Next, quadratic equations, how to use the quadratic formula, how to graph them, how to convert between standard and vertex form. And then you have rational expressions and radical expressions, solving radical equations, simplifying it, things like that. And every section has a quiz, so you can always review what you've learned if you have a test the next day. So here we have complex imaginary numbers. You need to know how to simplify those. Exponential, functions, logs. I have a lot of videos on logs. And then this is just functions in general. Vertical line tests, horizontal line tests, how to tell if a function is even or odd. And then conic sections, graphing circles, hyperbolas, ellipses, parabolas, and things like that. There's 2 video quizzes because it's actually a long section. And finally, arithmetic and geometric sequences and series. So that's my algebra course if you want to take a look at it, and let me know what you think.